Alright, so in this video I'm going to be going over how to utilize textures and materials properly in Unreal Engine. So this will give you a really good foundation of understanding how these things work, how to utilize them properly, and how to do more advanced things in the future based on these fundamentals. So I'm going to start with a quick breakdown of how the material system in Unreal Engine works and the different levels of it. So to start with, you have something called an HLSL shader. So HLSL stands for High Level Shader Language. This is essentially something that was developed by Microsoft back when DirectX 9 came out. And then it was standardized for a unified shader model for DirectX 10 moving forward. So essentially that's the foundation for the shader profiles utilized in the material itself. So the material in Unreal Engine is not a shader. It is utilizing shader code for the node-based material editor in Unreal Engine. On top of that, you have something called a material instance. This allows you to instantiate any material, essentially allowing you to have as many variations of that material as you like, where each instance is only going to load what's different about that instance, instead of reloading the material for each asset that is using it. You also have something called a material function. This is essentially a reusable block of code that you can utilize. So think of it as a material that you can then reuse in other materials. So it's essentially a prefab of material code, obviously all node-based, that you can then reuse over and over. This also adds another level of efficiency because you only have to have that group of nodes created once, and then you can just utilize the material function in any material that you want to. And then you can also instantiate that because it's, once again, just pulling that material function, figuring out what's different about it per use in a material, and then it just makes things a lot more efficient. And also just gives you less assets you have to worry about dealing with. All right, so those are the core components of the material system in Unreal Engine. And then obviously, a lot of the stuff that's done in Unreal Engine with the materials utilizes textures. So I'm going to be going over kind of the basics of utilizing textures in Unreal the proper way as well. So I'm going to start off by first bringing in our textures. I'm going to go over that first. So you'll see I already have our content folder structure laid out. So under content, I've created a materials folder, a scenes folder, and a textures folder. Under materials, I've got functions, I've got instances. Under instances, I have surface. This is basically any standard surface material that you use for any repeating texture set, right? So if it's not for a prop that has UVs and all that stuff, and it's literally just a repeating texture set that you'd use on a landscape or on a surface or something like that, it's going to go into the surface folder. And once again, this is just how I'm laying it out. You can lay it out however you like. This is just the most straightforward and easy to understand. And then under that, I've also got masters under the materials folder. This is basically going to be our master materials or parent materials, whatever you want to call them. This is the material itself that brings in the material function and all the other stuff that we're going to be using. And then I've got params. So params is going to contain our material parameter collections. This is something I didn't mention at the beginning of the video, but this is another, it's essentially a parameter that can be adjusted via sequencer in Unreal Engine, as well as some other different subtools in Unreal. So I'm going to show you how to set that up as well. It's another component of the material system that you can utilize. And then I've got scenes. This is basically just our level itself. Under textures, I have resources and surface. So resources is basically going to be our standard use textures we're going to be using for the master material themselves. So this basically gives you a very blank template for your materials, which makes it very efficient, especially if you want to take your material and migrate it to another project, make a copy of it. You don't have to duplicate all the textures and migrate all the textures that are with it. These are very small, very lightweight textures that you can then just have a very clean prefab to start with from your materials. And then the surface is going to contain our surface textures that we're going to go for our surface material instances, right? So I'll import those. So I'm going to start with that. So off screen, I've got a Explorer window open with 3 textures in it. I'm going to drag those in. Now when I drag it in, you'll see there's a little crossed out icon, meaning you can't import them. It's basically calculating the import or pre-calculating the import before you can drop them in. So you want to make sure that the icon looks like this before you let it go, or it will not import. So I'm going to bring these in and drop them. It's going to automatically import the textures. It's automatically going to detect the normal map based on the color values. It's very rare that it doesn't get this correct. Sometimes it'll even take a channel pack texture, which I'll go over in a minute, and interpret it as a normal if the color values end up looking similar to a normal map. Okay. So I've imported those. Now you see at the bottom left of the icons, they have a little asterisk. That means they've been imported, but they haven't been saved. So if you close your project or it crashes or anything like that before these are saved, while those asterisks are there, then they will not be in your project when you load it again. So I'm going to go to Save All. It's going to list those 3 textures. I'm going to save them. All right, so in the content browser, you can hold Control and use mouse wheel to scale up the icons essentially. So you can see here that we have ground001 is the name for our texture set. So a texture set in this case is what I'm calling the group of textures that comprises a surface. So we have our albedo S, which is albedo with the specular map stored in the alpha channel. We have MRAH, this is metallic, roughness, ambient occlusion, and height, all stored in the RGB and alpha values of the texture. This is channel packing. This makes things much more efficient and lightweight, and I'll go over that in a minute. And then you have your normal map, which is your normal values. So essentially, what we're doing with the channel packing is we're compressing 1, 2, 3, 4, 5, 6, 7 textures into 3 textures. Now what this does is it reduces the amount of files that you have to deal with, but it also reduces your overall file size. So if I had these textures separated into individual textures, so metallic, roughness, ambient occlusion, and height were each their own individual file, the file size would be roughly 3 times the size for all these textures rather than having them compressed into a single file. Now obviously that varies depending on the amount of detail that's in there and everything like that, but on average it's about 3 times the size. So you're saving a decent amount of file size by channel packing. And it also makes things more efficient, and you can sample each of those 4 channels in the material separately. Now another thing you'll notice with these textures, if I hover over them, I imported them as 4K. You can import 8K if you use virtual texturing and get that quality. A lot of the time it's not really worth it, but it just depends on what you're doing. If you want really high quality cinematic level of quality for your surfaces, or depending on the scale and all that good stuff, you may want to use 8K. But for the purpose of the tutorial, I'm keeping it at 8K or at 4K. But what you can do in Unreal Engine, you can actually use the non-destructive workflow to adjust this resolution. So I'm going to load up this texture, just double clicking on it. Now you'll see that it shows as transparent. That's because the specular map is stored in the alpha. So if I uncheck these values up here, you can see the specular map. In this case, this texture doesn't actually have any specular variation, so it's just a solid specular color. It's probably a default of 0.5 on 0 to 1 from black to white. So it'd be the default specular value. But if I uncheck alpha and check the RGB up here, you can see that I can see the texture itself, right? So you'll see here, if I hover over it, currently its zoom value is 31%. I'm on a 2K monitor. It's obviously going to depend on the texture resolution and the resolution of your monitor and screen size, all that good stuff. But it's currently set to 31% to fit within here because it's a 4K texture. If I go in and change this, I can do scale to fill. I can do 100%, 50%, whatever it is. Set it to 100%. So you can see the actual texture detail inside of here. If you hold right mouse, you can drag that around and view different areas of the texture if you want to. I can also manually zoom by using this, or I can use the mouse wheel itself. So I'm going to set this back to 100%, and I'm going to view it over here. So you'll see at the top right here, it has a bunch of details. So it has the imported, displayed, and maximum in-game resolution, which are all 4K because I haven't changed anything. You can see the resource size is 21 megs, almost 22 megs. So what we're going to do is we're going to go in and do a non-destructive down res of this texture. So I'm going to go over here and just do collapse all categories. I'm going to go under compression and advanced. Under here, you'll see there's a maximum texture size. Default set to 0, which means it's going to be whatever resolution the texture is natively when it was imported. But I'm going to go in and type a value. Now, if I type in a value that's not power of 2, let's say I do 2000, it's going to go to the next closest, which is 2048, and it will automatically downsample to that. So you can see that when I did that, it automatically updated the texture to 2K. If I go back and set it to 0, you can see it basically zooms back in, even though it's 100% on both of these views. That's because it is reducing the texture down to 2K. So I'm going to type in 2048. Now, the reason we're doing 2048 and not 2000 all stuff is you do want your textures to be a power of 2. There are a few reasons for this. One of them is just efficiency in general. You'll also get weird a glittering kind of a moire effect to the textures if you don't use a power of 2, because it can't do all the things like mip maps and all that stuff on the texture. So it's always going to look full crispness all the time, which, you know, sounds in theory like a good thing, but it's really not when it blends in with all the other objects in the world and everything like that. And it just creates some issues. So you always want it to be a power of 2. So that'd be like 2048, 1024, 32, all that good stuff. Now they don't have to be the same value in the U and V. So it can be 2048 by 1024 if you wanted to. That part doesn't matter as long as it is a power of 2 value. Now, another reason you want to use power of 2 is so that Unreal Engine can generate mip maps. So the best way to think of mip maps is a series of interlocking triangles that get progressively larger based on their distance and angle to the camera. So this allows the texture to always look the correct resolution based on distance and all that good stuff, but it also helps with performance. So it's essentially a level of detail for the texture itself, and it has quite a few benefits. And you can only get mip maps generated if the textures are a power of 2. So I'll show you very quickly what the mip maps look like. So if you look over on the right side here, it shows that there are 13 mip maps. The number of mips are 13. If I lower the resolution of the texture, let's say I go to 2048, you'll see that it lowers that to 12. If I go down to 512, it lowers that to 10. 128 lowers it down to 8. So the amount of MIPS generated depend on the resolution of the texture. But you can also view those MIP levels over here on the top. So if you go over here and check the box next to MIP level, you can select the MIP level from the drop down, or you can just click on minus to go through those MIP levels. Okay, so this is MIP, plus or minus. So I'm going to plus to go higher in the MIP count. Every time I click this, you'll see that the texture resolution reduces, right? All the way up to layer 12 or level 12 of the MIP, which in this case is going to be a 1:1 texture resolution, right? So as you can see, when I go back up through these, this is going to change, right? So that's showing what resolution each one of those MIPS is. So those MIPS levels are essentially a level of detail system for the texture itself, and they're extremely important for efficiency, performance, but also for visual artifacts. It helps eliminate those by allowing the resolution to adjust based on distance and angle. So you'll see up here, now that I've set this to 2048, you can see that our resource file size has gone down substantially. So it went from, if I hit 0 again, this is our original file size, basically just under 22 megs. If I set it to 2048, it's going down to 5.5 megs, right? So it's much, much smaller. Now the reason for this is when you go from 4K to 2K, for example, so 4096 down to 2048, it's not just half the size, it's actually a quarter of the size. Because, go back in here, I'm going to do scale to fit. So if this texture in its default state is 4K, right? So it's 4096 across and 4096 top to bottom. So 2048 by 2048 is actually going to be from here to here and from here to here, right? So it's this bottom right quarter, not just half of it, because you're taking both values in half, which is going to make it a quarter of the original size. Okay. Now obviously this would be different if this were a 4K by a 2K and you dropped it down. Then it'd only be essentially going in one direction for that, but it's still going to be a quarter of the size, right? So just keep that in mind when you're working with your textures. In most use cases, you don't have to use 4K or 8K, 2K, sometimes even 1K works very well. So you can actually do this on a group of textures at once, all that good stuff. And usually that's what I do is I will work with the highest quality that I think I will need or to make something future-proof. So it might be 4K or 8K when I import it. And then I will downsample per use case or per object or whatever it is, depending on what's actually needed for what I'm going for. This helps with efficiency, it helps with memory management, all of that good stuff, and it's just really, really a good thing to do. Now, the reason this is non-destructive is because the original asset I brought in is always going to be 4K no matter what, unless I re-import it as a lower resolution. So that means if I drop this down to 2048 or 2K, you can see the imported shows 4K, displayed in max in-game is 2K. So basically what this means is the editor will always keep that 4K version, But when you go in and compile whatever you're trying to build, your game, your experience, it doesn't really matter. It's going to only build it with the value that you set here. But you can always go back to the editor, and the editor will have stored the 4K version, even though it's going to be displaying the 2K version. So this gives you a lot of freedom and non-destructive workflow, which means you can always go back to the original source assets. All right, so that is how you go in and adjust your texture resolution non-destructively. Now, another thing I'll show you is how to do that in bulk. So I've only got 3 textures here, and you can see I made a change to it. So I'm just going to save, right? Once that asterisk is there, that means it's been modified and hasn't been saved. So I'm going to select all 3 of these. I'm just going to shift select. I'm going to right click. I'm going to go to Asset Actions and go into Edit Selection in Property Matrix. This will allow you to bulk edit assets. Now I'm doing textures right now, but this works with any group of assets. You can even do different types of assets together, so like meshes, textures, materials, all that. But keep in mind that the parameters will only allow you to bulk edit if they have shared parameters. So all textures are going to have the same parameters, whereas textures and meshes will have different sets of parameters. So only those parameters that they might share will show as bulk editable if you have them all selected, right? So you can do Control A to select everything. You can do Shift Select, doesn't really matter. So I'm going to select all these. You can see it gives us our basic values up here. So what I'm going to do is go into Compression and then Maximum Texture Size. So now I can go in and type 2048, right? Hit Enter. It's going to update. It does it pretty quickly, depending on how many textures you have selected and the resolution, obviously. So now these have been updated to 2K textures. So if I hover over it, you're going to see the dimensions still show as 4K. That's just because that's what it's been imported as. But you can see that the maximum texture size, if you go basically 4 lines from the bottom of this contextual menu, shows 2048, right? So those have all been edited. And then you can see that the asterisk is down at the bottom. That means they have been modified but not saved. So I'm going to set this maximum texture size back down to 0. So it'll use the original texture size, hover back over it, and you can see that maximum texture size shows 0 down there, which means it's defaulting to its original size, which is 4K. Okay, so I'm going to save all that. Now another thing to take note of is, let's say for example you import a texture and it wasn't interpreted correctly, so it automatically interprets normals. But let's say it interpreted your channel-packed surface textures as normal, or it did not interpret your normal correctly. You can always modify that as well. So if you load up the texture, once again you can just double-click it. You can go over here under Compression and choose your compression settings, right? So default, normal map, etc. So you can change that there if you need to. It's very, very rare. You may not even run into it that you have to do that, but if you do, that's how you do it. Cool. All right, so we've gone over the texture import and process for all that good stuff. Now, if I go back over to resources, you can see that I have 2 textures here. I have a blank texture, which is just pure white, and I have a blank normal texture. The blank normal texture, the color value for this is RGB 128, 128, and 255. This is the default color for a surface for a normal map. This means it will not change the direction of that surface normal. And a normal map, if you're not familiar, is essentially a color value that tells it which direction the surface is actually facing. So this allows you to fake surface detail, right? So you can have angles and all that good stuff. So the default flat value for that is going to be 128, 128, 255 for the RG and B values. Now you also notice when I hover over these, sort of 2/3 from the top of this, or 1/3 from the bottom of this contextual pop-up, you'll see it says dimensions are 32 by 32. So it's a very small texture. Now the reason I have these is these are going to be our sample textures when we build our materials. So we can go and replace these with whatever we want, but have a very low profile and efficient material template that we can reuse over and over and migrate and all stuff without having to bring in textures. And it also gives us a very blank slate to work with when we create instances. So we're creating this really nice template system that we can reuse over and over again. All right, so what I'm going to do now is I'm going to start by creating a master material. So I'm going to go into Masters under my Materials folder. I'm going to right click and I'm going to create a material. I'm just going to call this example 001. Now, naming convention is sort of a contentious topic with some people. It really depends on what your goals are and all that good stuff, but it does make a huge difference when you efficiently name things and organize your folder structure and all that, especially when you're working with a team. You want to be able to disseminate how to decipher and interpret how you've laid out your folder structure when you interchange these files and projects between different team members. Also, when you're working just by yourself, it just makes it more efficient. And then when you go in and migrate into another project, for example, and you keep your structures the same throughout, it's going to make it very easy to migrate all those things. So you always want to be thinking a little bit more future-proof, not like, oh, I'm going to name this as quickly as I can and you just get it all done and import stuff and then, I'll deal with it later, because down the line that can really impact your efficiency and also how long it takes to get things done and also the cost for things when you're actually working with a team or trying to develop something. So once again, it's up to you. This is just a structure I usually use and use with my teams. So I've created a master material. Once again, just right-click, go into Material and Material. I'm now going to load this up and close this. That details panel down there will basically show you your shader complexity and all that. And actually for now, I will just keep that open. Stats. Okay, so you can see here it shows our base pass shader instruction value, our base pass vertex shader instruction value, our texture samplers being used, all of that good stuff. Right, this is just the basic out the gate utilization that's happening. Okay, so I'll close that for now. Over here, this is your root node for everything. So this is what you're going to plug all of your nodes into to get the values that you want for your material and eventually your material instance. So I'm going to start by just creating a very basic material that's going to have a solid color value, metallic, specular, and roughness values. Okay. So what I'm going to do is I'm going to start with a base color. So for this, you can drag the pin off if you want to and type in something that you're looking for. So let's say a vector 3 or a 3 vector. Okay, a constant 3 vector. So you can do that. It'll automatically attach it. And then there you go. You have your color value that you can then go and tweak. So if I go in here and let's say I make this red, hit OK. You'll see it update on the surface, or it's more of a pink, but you'll see it update on the surface over here, right? I'm just going to move this a little bit so the aspect ratio doesn't get weird. Okay. So you can do that. I'm going to set this back to a default value. Anytime you see one of these little curly Q arrows, you can reset a value. You can also manually type in values here. You can double click this to get the color swatch, or you can double click this. Okay. Now another way you can create this, I'm going to delete that, just clicking it and hitting delete, is to hold 3 and then left click. That'll be your 3 vector. So I'm going to plug this into our base color. Now for metallic, specular, and roughness, these use a constant value, so I'm going to hold 1. Or if you right click, okay, so I can just do a constant, right? So I do that, that's a 0 to 1 value. It can obviously be more than 1 or less than 0, but in most cases it's going to be 0 to 1. So metallic, specular, and roughness are always going to be 0 to 1. So 0 to 1 represents black to white. So if you have a texture plugged into this, the black values are going to be at the one value, and the white value is going to be another value, and anything in between will be a gradation of that. So for metallic, for example, 0 is non-metallic, 1 is metallic. Specular, 0 is non-specular, 1 is full specular. And then roughness, 0 is completely non-rough, and 1 is completely rough. So shiny to not shiny. Okay, so I'm going to delete this. Now you'll see here that there are default values in here. You can manually change these if you want to by double-clicking and typing. These default values are going to be the defaults for the material. Usually when I create a master material, I like to keep the default values for things like metallic, specular, and roughness. So that way you can go in and just have a clean base to work from, like I mentioned before. So another way you can create that constant is to hold 1 and left-click. So I'm going to do that. I'm going to create 3 of those. Now another thing I could do is, let's say I didn't want to hold 1 and click 3 times. I can select one of these and hit Control D to duplicate. Now when I duplicate, whatever I have selected is going to be duplicated. So you can see this yellow outline around it. And wherever my cursor is, the top left of this node is going to be duplicated to that. So right there and right there. I can also do copy, paste, Control C, Control V, and all that. Okay, so in this case, I'm just going to hold 1 and left click and create 3 of those all together. And I'm also going to give these default values that match with these default values, right? So as soon as I plug this in, this is going to override those values. So if I take, let's say, for example, this one, and I plug it into specular, you'll see that value disappears, and it's going to be using this, right? So what I'm going to do is set this to 0.5. I'm going to set this to 0.5 because this is going to be my specular and roughness. And my metallic is already 0, so I'm going to take that and plug it in. So metallic specular, and roughness. Okay, so I've got those plugged in. Now another thing I want to do is just kind of keep things organized a little bit. So I'm going to move this one up here. It doesn't matter where, they can be shifted off and all that stuff. And essentially what I'm going to do is I'm going to distribute these and align them. So it's going to go for vertical distribution. It's going to go by the distance between your bottom node and your top node and shift everything in between accordingly. So I'm going to take all of these, I'm going to right click, and I'm going to go to alignment. And you'll see that I have all these alignment options, right? So what I want to do for this is distribute vertically. This will evenly space them out vertically. And I want to align them to the right. So they'll all be in line like this. It just keeps things clean. And with all these selected, I can slide them up. Now, another thing you can do in the material editor is you can comment things out. So I'm going to select this and hit C on the keyboard for comment. I'm going to call this color. And over here, you can adjust the comment box color, font size, all that. So I'm going to set this to a font size of 12, just so it's a little bit cleaner. And I'm just going to make it red, right? So I'm going to make everything 0 except for R. You can also go and adjust the opacity of this with the alpha value if you want to. So if you make it completely 0, then just the bar at the top will be the color you've selected. Okay. I'm going to do the same thing with these 3 nodes. I'm actually going to bring these a little closer together here. And once again, I can just distribute these vertically and make sure that they're still right aligned. I'm going to slide these down together. I'm going to comment them out. So I have all 3 of these selected. I'm going to hit C. I'm just going to call this surface. I'm just going to make this value green. Right, so now we've commented these out. We can also take these comment boxes and we can align these, right? So I can align right, I can distribute all that good stuff. You can also just grab these and move them around, and it'll basically treat its commented group as a group that you can move, which is very useful. Now another thing you can do is if you want to disconnect any of these pins, you can hold Alt and left click on either end of the pin or the pin itself, and it'll disconnect it. You can also double click anywhere along the string and it will create a reroute pin. So in order to move this, you hold Control and then drag it around. And if you want to create multiple reroute pins, you can do that as well. And this will basically just allow you to organize your strings a little bit better. Okay. All right, so now we've got the color value, we've got the metallic, specular, and roughness, all with the default values. But what I want to be able to do is control these via a material instance. So I need to make them into parameter values that can then be controlled by an instance. So I'm going to save this material. Now, actually, before I do that, up at the top, you'll see that there's the ability to apply the changes to your material, and then you can save. So what's cool about apply is you can apply changes, see how it affects things in your world or with your instances, and then you can close it without saving it, and it will reset the values if you want to revert those changes. So I'm just going to go in and save because I already know that this is going to be good. Another thing to take note of is this live update. So if you go up here, it says preview material. This is on by default. It will automatically update your material preview as you're making updates. When you get into more complex material setups, sometimes this can take a while. So if you really get comfortable with what you're doing and you know you can really make any mistakes, or if you're not worried about making a mistake because you can go back and fix the error, it's best to disable this. That way you can just work quickly without it doing a recompile every time you make an adjustment. Okay, so I'm actually going to disable this for now because we don't really need it for this video. Okay, so what I want to do is create these or modify these to work with material instance. So I'm going to just align these for visual purposes. So I'm going to scale these out so they align. And then what I'm going to do is I'm going to select this first one, and I'm going to right click on it and convert it to a parameter. This is going to make it so it can be modified via the material instance, so it can be instantiated. And you'll see as soon as I do that, it asks for a name. It's already highlighted. I can also input the name over here if I want to, and I want to give it a name. So in this case, I'm just going to call it color. Okay. Now over here on the left, you can see I've given it a parameter name, which I can change at any time. It's got the default value here. I can also give it a group. So the group name is basically going to be the group inside of the material instance that it resides in. So in this case, I'm also going to call that color. Oh, get rid of that dot. And then sort priority. So this is the order in which it's going to be sorted in the material instance. Now this is extremely important when it comes to organization and all that stuff. Once again, you always want to carry along that organizational structure throughout anything that you do in Unreal Engine or anything you do in general. So I'm going to set this to 0. If it's the only one in its group, the sort priority obviously doesn't really matter, but I'm just going to set it to 0 because I may add some other things in later. You can also give it a description. Now, the description's nice because it can basically, especially when you get into more complex node trees for your materials, it can make things a lot easier to organize and correlate and figure out what's going on. So that comment, or the description, is actually this 3 dots here. So if you hover over the node towards the top, you can see these 3 dots pop up, and I can give it a description. Color of the surface, right? And that will always show up there. And if I zoom in and out, you can see it adjusts with the view. I can also toggle whether or not to show that comment bubble. And if I hit pin, it'll always stay the same size even when I zoom out, so it's easy to kind of spot where things are. Now with more complex node trees, that can be a little bit annoying, having them all the same size when you zoom out, but you can do it one by one too if you're just trying to figure out where it fits in with an entire node tree, or if you're trying to dissect something else that someone else built. Okay, so now we've converted this to a parameter, we've given it a description, and now we're going to convert these into a parameter. So I'm going to select all 3 of these. I could have selected all 4 at once and converted them, but I wanted to show you individually first. So I'm going to take all these, right-click, and convert these to a parameter. I'm going to select all of these, and I'm going to put them into a group called surface. There's going to be things like our, once again, metallic, roughness, specular, even our ambient occlusion and all that stuff, which we'll get into later. Okay. And once I convert them to a parameter and all that, they're going to become a little larger nodes. So I'm going to drag them back in here. And I'm going to call this first one metallic. I'm going to call this one specular. And I'm going to call this one roughness. Now, a lot of people, for some reason, like to use very complex names or names that don't really make sense, maybe they just make sense to them, but they can be very straightforward. They don't have to be, a programmer language. And especially when you're trying to art direct and all that stuff and working with artists, it's just much easier to have nodes that are descriptive and clear and all that good stuff. So you can see here we have color, our metallic, specular, and roughness value, right? So metallic, specular, and roughness are only going to be 0 to 1 values. You can, if you're using them as a modifier for a texture, which I'll go into later, they can be more than that or less than that. But what I want to do is set these default values, or the maximum and minimum that we can adjust these to 0 and 1. So you'll see over here, I have all 3 of these nodes selected. We have a slider min and a slider max. They're both set to 0, which means I can go negative values or over 1 if I want to. But if I go into slider max and type in 1, it's going to clamp it between 0 and 1. So I can no longer go negative values or positive values. This just makes it much easier to control because when you're adjusting the slider, you'll be able to go beyond or below 0 to 1 values, and the slider itself just doesn't really have any limits. So it's just easier to have it set up this way for values that you'll never go below 0, above 1. And then down here we have it grouped into surface, but what I want to do is adjust the sort priority, and I want it to be ordered by the order that it has in the material system. Once again, this is just part of efficiency and just makes it easier to art direct. So I'm going to set the sort priority for metallic to 0, specular to 1, and then roughness to 2. Okay, so these will be ordered top down in this same order in the material instance. Cool. Now I can go in and add a description to all of these. I'm not going to do that. I just did it as an example here for the color value, just so you know that you can do that. So I'm going to go up here and save. And now I've created my first material, very basic. It's got a solid color and then a metallic, specular, and roughness value. So what I'm going to do is I'm going to click up here and basically find this material in the content browser. So I'm going to close it out. I'm going to right click on this material and go into create material instance. So what it's going to do is automatically create an instance, and it's going to be the same name with underscore inst for instance. So I'll just keep it that way for now. And what I'm going to do is I'm just going to drag this into my instances surface folder. Because once again, we want to keep our instances and everything separated. And then I'm going to load up this material instance. Okay, so when I do that, you can see we're greeted with a preview window here. I'm going to make sure it's set to real time, which by default it does not. So you want to make sure it's real time, so any changes you do, you'll be able to see instantly. Now in this preview window, I'm going to go over this a little bit later in a UI overview video, but if you hold L and use the left or right click, you can move the light around. You can also use the middle click. Once again, just holding L. So if you need to adjust it for your view, you can do that. Over on the side here, I'm going to collapse these for a second. You can see that we have our color group that we created, and we have our surface group that we created, and all of our instance parameters are in those groups just as we laid them out, and they're also sorted in the order that we gave them, right? So I want to show you really quickly. I'm going to go back to our, well, actually I can do it from here. I'm going to go back to our master material just so I have it open. So what I just did is I expanded general and I double clicked the parent. So the parent is going to be the parent material or master material, the one that we just created. Anywhere you see a thumbnail for any asset, if it's this or a static mesh, whatever, you can double click on it to load its editor, right? So I just loaded it from here and it popped up in the same tab group. Okay, so I'm going to minimize that. I'm going to go back into some of this a little bit later. So if I go into specular, you can see that our default value is 0.5, and you can see our slider is right in the middle, and it has a minimum and maximum value, right? So max 1, minimum 0. If I go back into here, and I go into our specular, and I get rid of our slider max, that just kind of shows you what I'm talking about. You can see that now, if we slide this, there's no maximum value, and the slider sensitivity is based on that, right? So if you have 0 to 1, it's just going to be a little bit easier to control, especially if you're never going to go below 0 or above 1. That's the reason I gave it a slider minimum and max value, just to kind of visualize that. So I'm going to set that back to slider max of 1, and then our slider is going to be much easier to manipulate like that. All right. So what I'm going to do is I'm going to start by giving it a color. So I can, in order to change any values in the instance, you just check the box. You'll see it becomes enabled, and you can change those values. So let's say I want to make the surface just pure red. I can go ahead and type 1 for the red value. If I go above that at all, it's not going to make any difference because there's no value above 1 for red. It's either 0, 2, 1. As to how much red value there is. Now you can obviously combine these values. So if I start putting in a little bit of green, it'll become more orange. I can bring in some blue if I want to and make it more of a purple, right? Just gonna go back in here for a second. All right, just making sure. All right, so I'm gonna set this to kind of a purplish color, something like that, something that reads well on the video record. That should be pretty decent. And then what I'm going to do is I'm going to go in and adjust our values down here. So you can see we have, once again, metallic, specular, and roughness. So metallic is very straightforward. It makes the surface metallic or non-metallic. I'm going to set that to 1. So now this is a metallic surface. And in order to, if you ever want to keep a value, but you wanted to like disable it, you can just uncheck the box. And if you check it again, you can toggle between the two, right? So the value that you entered and then the original value. So that's what it looks like as metallic. I can also go and adjust our roughness value. So I bring it all the way up, it's going to be fully rough. Bring it all the way down, it's going to be fully non-rough. Okay, and you can see that with and without the metallic value. Now the specular value only works if metallic is not set to 1. So if we go and adjust our specular value now, you're not really going to notice any difference from it. But if I disable metallic and I start adjusting our specular value, you can see that it affects how reflective the surface actually is based on the roughness value. So if you're fully non-rough and you're fully specular, that's as reflective as you're going to get. And this is useful for things like water and glass and stuff like that. And obviously the specular value is going to be when your lights hit the surface and everything like that, right? And you can still keep the specular bumped up and then bring the roughness down and vice versa, right? And you can see how the specular values adjust. Now, once again, I'm using 0 to 1 values for this, but metallic, specular, and roughness can also be textures that are black and white values, right? So you can have variation on your surface. That's how you get variation in your roughness values and specular values. So let's go in and make this a little bit more complicated. And what I'm going to do is I'm going to create a material function, right? So I mentioned material functions earlier. They're essentially a prefab block of material nodes that you can utilize over and over again. So I'm going to go into my materials and functions folder. I'm going to right click, go to material advanced, and create a material function. I'm going to call this color Fresnel because we're basically going to create a color Fresnel value, which I'll go over in just a second. So in order to do that, I'm actually just going to take this node that I've already created, including the comment and everything. I'm going to cut it. So I'm going to do Control X. I'm going to load up our material function that we just created, color Fresnel, double click on it. And I'm going to paste that in here. Okay. So by default, you have an output function here. Anything that plugs into this, you can then output again into your master material. So I'm going to take the RGB value, which is this pin here, and plug it in. So you'll see on this color node that we have RGB combined, as well as the alpha. Everything for this is all combined into one pin. You can also isolate red, green, blue, and alpha independently if you want to, which depends on what you're using it for. So if you're going to use this for a texture, for example, and you want to utilize the channel packing, you're obviously going to want to sample the RGB and A separately. Okay, so I just plugged that into this output result here. So I'm going to change the name of this output result to base color, which is basically going to correlate with the base color pin here. So essentially what I'm doing is telling this what the output pin is going to be that it should be plugged into, just to make it easier to reference and ArtDirect and all of that good stuff. Okay, so what I'm going to do is just hit save on this. I'm going to find this in our browser once again by clicking the little folder with the magnifying glass on it. I'm going to go back into our master material and drag this in. Okay. So this is our material function that we just created, but it's imported as a node. Now, if you want to create this without dragging it in, you can also right-click and go to function and do material function call. And it'll automatically utilize whatever you have selected in the content browser. In this case, I've already got this selected. But if you want to change that value, you can do it from the drop-down here. You can search. You can also select something in the content browser, click on this arrow, or with the function selected, you can just drag that in here, right? So we've already got it in because I just dragged it in from the content browser. So I'm going to plug this straight into our base color. I'm going to save this. I'm going to go back to our material instance, and you can see that our values are exactly the same, right? Because we literally just copied and or cut and paste our color value that we already had with the same name, same group, sort priority, all that good stuff, into our material function, even though we'd already created this in the material itself. But now we're separating it out into a material function that we can then reuse over and over again, right? So that's how a material function works. So this is called color Fresnel, so we do want to make this a Fresnel color. So what I'm going to do is expand out this comment box. I'm going to drag this over here. I'm going to duplicate this. I'm going to call this Control D. And I want to change the names of this. So I'm going to call this one inner color and outer color. Another thing I want to do is change the sort priority because we have two of these now. So this is 0, this will be 1. And what I want to do is create a linear interpolate, which you can just go in here and type in lerp, and it'll create a linear interpolate. Another way you can do is by holding L on the keyboard for linear interpolate and left clicking. So now what I want to do is take this output base color, which I'm going to right click on this and do stop previewing node. This is what the node looks like normally. I'm just going to bring this in. Now you don't have to do that stop preview. I just go a lot by color and labeling inside of the material editor, so it makes it quicker knowing what the original colors for this these nodes are, right? They can just quicker reference. And once you start doing a lot of these, it becomes kind of second nature. So I took this output, which is our base color, the pin from here, and plugged it into here. Now I'm going to take this, the A value, and plug it into the inner color. B value will be our outer color. For the purpose of this, I'm just going to get rid of the descriptions, just so they're not in the way. So I'm going to interpolate both of these values. So basically what this means is it's going to interpolate between this color and this color based on an alpha. So essentially 0 down here is going to be the inner color, 1 will be the outer color, right? So if I just set this to 0.5 for right now, and I'm going to hit save, I'm going to go to our instance. You can see that we have an inner and outer color value, right? So I'm going to set this one to red. I'm going to set our secondary color to blue. So essentially what it's doing is interpolating between red and blue at a 0.5 value. That means it's blending them together perfectly in the middle, so it creates purple. So if we go in here and change this alpha value to 0 in our lerp, it's only going to show the inner color, which should be red. Go back to the instance. Now you can see it's only showing the red color. It's ignoring the blue color completely, and that's how it interpolates between the two. And I can obviously adjust this value independently. But what I want to do is have this controlled based on a Fresnel value. So to kind of demonstrate this a little bit easier, I'm going to hold 1 and left click. I'm going to create a parameter real quick just to show you. Lerp demo. I'm just going to call that lerp demo. I'm going to throw that into our color group. Once you actually create a group by typing it in here, it will show in the dropdown. So if I have multiple groups in here, it'll show them all in the dropdown, which is really cool. So we have 0, 1, and this will now be 2 sort priority. and I'm going to plug this into our alpha. I'm going to give it a default value of 0.5 and a maximum of 1, so we have an easier slider to work with. I'm going to hit save, go back into our instance, and now our lerp value, so it's going to interpolate linearly. Once again, 0 is going to be the red value, or the inner color. 1 will be the blue value, or the outer color, right? So that's how it's interpolating. But what I want to do is make this interpolate via Fresnel. So I'm going to take this, I'm going to delete it. I'm going to right click and look for something called a Fresnel, F-R-E-S-N-E-L, and bring that in. And then I'm going to hold 1 and left click, convert this into a parameter. Call this color Fresnel, put it into the color group, and sort it as value 2. So we have 0, 1, 2. And I'm going to put the exponent into here. I'm going to plug the alpha value into this. Now what I want to do with this, I'm going to give it a default value of 2 and a max of 5. I'm just going to organize these nodes a little bit better so it's cleaner to look at. And I'm going to align right, distribute vertically, and then that one's already good there. Cool. So this is our entire node tree setup for our Fresnel color. So I'm going to hit save. And I'm going to go into example instance. And now you can see that it is blending between the red and the blue value based on a Fresnel. So the Fresnel is essentially going to interpolate based on the surface's angle to your view, right? So the surface's angle to the camera. So as you can see, the outer color and inner color are blending based on that. So essentially, the farther away the surface is from the camera, from 0 to like 90 degrees, obviously, the more it's going to blend into the outer color. And then the more straight onto the camera it's facing, it's going to blend into the inner color. So I change this over to a cube by changing the mesh that I'm viewing on. You can see that that holds true here as well. And cylinder, same thing. You can see it's based on its view angle to the camera. And do it on a plane also. Cool. So I'm going to go back in here. Now I can go and control this Fresnel value. This is basically the gradation between those two values, how much it averages that distance. So I can get some really cool effects with that, right? Now if I want to go ahead and use the shader ball for this, I can too. So I've already got the shader ball in our scene. And I can just find this mesh in the content browser. If you ever want to find the shader ball in the content browser, all you have to do is go into the engine folder here, and then type search, and type in matte preview or matte p, and this mesh is in here by default. Okay, so I'm going to bring the instance back up here. So with that mesh selected, in any preview window in Unreal Engine for materials and all that stuff, you can click on this little brick icon and it'll use the mesh that you have selected in the content browser for the mesh preview. Okay, so you can see how that Fresnel looks on this. And as I go in and adjust the color Fresnel value, you can see how that works. Right. And then we can go in and adjust, once again, our specular and roughness. Also, I'm going to bump the specular all the way up, bring the roughness all the way down, and you can see what a cool looking surface that is with just using very, very simple Fresnel color values. And I can obviously go in and change these colors whatever I want. I'm just using red and blue as an example. Let's say I want the inner color to be like a, say like a greenish blue, and maybe the outer color becomes more of like a purple. I can go in and do that too, right? But for now, we'll just keep it as red and blue. Okay, so that is the basics for utilizing a material instance, a material function, and a master material. So now what we're going to do is do the same thing for the surface and just create a function out of it. So I'm going to go back in here. I'm going to cut this, Control X. I'm now going to go back into our materials and functions folder and create a new material function. Once again, right click, material, advanced material function. I'm going to call this one surface underscore basic. This is going to be our surface parameters. I'm going to double click this And once again, we already cut those nodes. I'm going to paste them, Control V. And keep in mind this control paste and everything, can copy paste, all that. You can actually do that in between projects too. It doesn't have to be in the same project, which is very useful. So I'm going to go back over to this node. Once again, I'm going to right click Stop Previewing just for the color and ease of use. And what I'm going to do is just name these this output to correlate with the nodes it's going to plug into. Because once again, this is what it's going to pin out to into the master material. So I can take this output node and duplicate it. So I'm going to duplicate that twice. You can also select these nodes and do the same thing to distribute and align. In this case, I'm going to align left. And I'm going to name them accordingly. So we have metallic, specular, and roughness, right? And I also want to sort priority these. So I'll show you why before I do that. Just distribute these real quick. Oh, roughness needs to be fixed. Okay. So I'm going to plug roughness into here, specular into here, and metallic into here. I'm going to save. I'm going to find this in the content browser, go back to our master material, and I can just duplicate this and then change it to the one that I have in the content browser because I've already found it in the content browser, right? I did that little find and then just duplicated. Once again, these are all just time-saving things. So you can see right now it's ordered specular, roughness, and metallic, right? So it's by default going to order alphanumerically unless you give it a sort value, okay? So I want this to be ordered in the same order here just for clarity and cleanliness and organization. So I'm going to go back in here. I'm going to set metallic to 0, which it already is. Specular will be 1, and roughness will be 2. Save that. Go back into the master material, and now you can see metallic, specular, roughness are ordered in the correct order. So metallic, specular, and roughness. So now we've basically taken everything that we created earlier and created functions out of them, which we can then reuse in multiple materials, and you can see how clean and everything that the material itself looks. If we go back into the instance, you can see all parameters remain the same. Okay. Now, another thing to keep in mind is that Fresnel value I showed you for the color, it can be used for anything. So if you wanted to have a Fresnel value that changes the specularity around the curvature of a surface or the angle to the camera or the roughness or anything like that, you can do that as well using the same technique, just applying the constant nodes rather than the color nodes and plugging them into the appropriate pins. Okay. All right, cool. So now we have our surface basic material function here that we can reuse over and over again. We have our color Fresnel material function that we can use over and over again, and everything is working how we'd expect. So I'm going to close all of this, save it, just to make sure we keep everything. Okay, so you can see we have our functions, color Fresnel, surface basic. We have our instance surface of our example 001, and we have our master material, right? So I'm going to go to our instances surface, and I'm actually just going to apply that to this asset. So you can drag and drop it onto the actual material ID of the asset. So if I go and drag it onto this, it'll be that. If I go and drag it on here, it'll be there. Or you can just apply it here. It shows the material elements here, right? So the reason I'm only applying to the 1 and not all 3 is because what I'm going to do is create 3 versions of this instance so you can see how you can change the values for each one. So I'm going to duplicate this. Once again, Control D. I'm going to call this instance. Actually, you know what? That does make a little more sense. So I'll call this instance 1 or 001 instance B. Call this one instance A, and this last one will be C. Okay, so we basically have 3 instances based off the same material. Once again, it's just going to load 1 for each time that it's used, and then it's just going to load the material once overall and then figure out what's different per instance, right? So I'm going to start from the left, do instance 1, or sorry, let's do instance A, instance B, and instance C, right? So left to right, just to make it a little bit easier to follow. So, okay, so I'm going to keep A as is. I'm going to go into B. And another thing you can do is once you have this open, you can click on this little blue tab here in the corner and close any panes that you want to. In this case, I'm going to close the viewport because I'm going to view it in the actual editor viewport. And then I can take this and keep it over to the side here, right? So this is our B instance. So I'm going to change the color values on this. Let's go in and let's just make this green, and let's do another color that works with that. Let's try blue. Cool. So I'm going to load in our C value, which is the one on the right here. Oh, and actually, once you make that change, if you close out the window and then load it again, that change will remain no however many times you load again. That's the reason it still showed the preview window even though I closed it the last time. All right, so in this one, let's just change the specularity and roughness values. Right, so now you can see we've got metallic and, or sorry, specular and non-rough, fully specular non-rough. Right here we have 0.5 for both, right? And maybe we'll add in a metallic value to that on top of it, right? So now you can see how the instances work very, very efficiently. So all three of these instances are only loading that material one time, and all the material functions, everything utilized with it, and then only figuring out what's different per instance for those parameters and making those changes. So it makes it much, much more efficient when you're working with this material setup. Okay, so the next step to our material basics here is going to be utilizing textures. So I'm going to go into our functions. I'm going to create a new function. I'm going to go under, once again, Material, Advanced, and Material Function. I'm just going to do Textures PBR, Physically Based Rendering. Make it very straightforward. I'm going to load this up. Now what I want to do is bring in our textures to sample, right? So I'm going to go into our textures and surface. So we have these three textures here. Once again, our ground 001, albedo specular, metallic roughness, ambient occlusion, and height, and normal, and these two are channel packed. But what I don't want to do is just bring these textures in and have them be the default textures. I want to use the resource textures that I showed you because they're much lighter weight and better for creating a material template. So I'm going to take both of these textures, and I'm going to drag them in. Okay. Now the reason I have a blank normal and a blank texture is because the sample type for the texture depends on the type of texture it's utilizing, right? So you can see when I click on this one, which is our normal, it knows it's a normal map, so it's going to set the sampler type to normal. This one, it knows is a standard color texture, so it's going to sample it as a standard color texture. This is extremely important because if you're trying to use a normal map in the color sampler type, it's going to look weird, and vice versa. So the sampler type is very important. Now another way that I can create these texture samplers was by holding T and left clicking. It'll automatically utilize whatever I have selected in the content browser, or I can right click and look for texture sample. There are also other different types of texture nodes, but we're going to be using these for the purposes of this video. So I have my two texture samplers, but I need a third one. So I'm just going to duplicate this one because we have two color samples and then one normal, right? And if I go into surface again, you can see we have, once again, our albedo, our MRAH, and our normal in that order. So I basically want to replicate that order vertically in here. So we have our three texture samplers. I'm going to align these, distribute vertically, and then align right, just to clean everything up. And then what I want to do is convert these into texture parameters so that we can then swap these textures out in the material instance. So I'm going to select all three of these, right click, and then convert to texture, or convert to parameter. I then want to select all these and I'm going to put them into a group called textures. Now another thing you can do to order the groups is if you want to, you can do like A and then a pipe and then textures. It'll alphanumerically order the groups as well as the parameters inside of them because the groups themselves do not have sort priority, only the parameters, right? So if you want to do that, you can, and that's usually what I do with my texture sets, or my materials anyway. So in this case, I am going to do that. Let's do A, pipe, textures. So I want the textures to show up first. And I'm going to give them a sort priority, so the first one will be 0, 1, and 2. And then for this one, I'm going to give it a prefix of texture, pipe, and then albedo S, right? So we know which texture is supposed to be populated in this texture slot. And then I'm just going to copy that prefix. I can double click, paste it, and then I can do the next one, which is going to be MRAH, metallic roughness, ambient occlusion, and height. And then the last one, which is of course normal. So all I'm doing is pasting that prefix, including the space before, and then just typing in the value. It makes it very quick and efficient to go in and add your texture samplers and organize that way. Okay, so we've got that set up. I'm going to select all these. I'm going to comment them out. Once again, selecting all of them, hitting Control C. I'm going to give them a give the comment a value of 12 for the font size, like I did before. And I'm just going to make this blue in color. And now I'm going to input these out or output these. So the way we can do this is we can take this output, once again, stop previewing just for the color value. I'm going to call this base color. Whoops, base color. Because once again, we want to basically name this on what the output is going to be, just so we know where to plug it in. And I'm going to plug this in the RGB value of our albedo S. I'm going to duplicate this, and then I'm going to plug this into the alpha. This is going to be our specular. Okay. This one will have a sort priority of 1. Duplicate this again. This will be our metallic. And what I'm going to do here is I'm actually going to duplicate 3 more. So specular, roughness, and AO. Or actually, sorry, this should be metallic, roughness, ambient occlusion, and height. So we're not going to use the height for this tutorial. I'll cover that in a little bit later video. Take all these. I'm going to align them to the left and make sure they're distributed. Okay, so I'll name these accordingly based on what they're going to be sampling. Okay, and then our sort priority starting from 1 is going to go back to 2, 3, and then 4. I'll duplicate the AO, call this one normal, and this will be sort priority of 5, right? So now these are the sort priority is accurate for each of these. Okay, so I'm going to plug these in. So normal into the RGB value of our normal texture. Metallic is going to sample the red channel. Roughness will be green, and AO will be blue because we've channel packed MRAH, metallic, roughness, and ambient occlusion, and then height, which we're not sampling, which will be the alpha. We'll go over that in a later video. So I'm going to take all these, and I'm going to align them to the left, and then everything here looks good. Okay, I'm just double checking. All right, so now we have everything sampled. So we have our base color, which is pulling the RGB values of our albedo S texture. We have the specular, which is sampling the alpha channel of that, where the specular value is. We have metallic, roughness, and AO being sampled from our MRAH, and we're not sampling the height. And we have normal sampling the RGB of our normal texture sampler. So I'm going to take all that, hit save. I'm going to find this in the content browser. I'm going to go back to our masters, and I'm going to duplicate this one, our master, and it's going to be called example 2. I'm going to load that up, go back into our function, and I'm going to bring this textures PBR into here. So I'm going to get rid of both of these, and I'm basically going to bring in our base color, specular, roughness, ambient occlusion, and our normal. Now you'll see that the order of these is not the same as the order here, which we do want to keep, and I also want to plug in my metallic, obviously. So I want to order this based on this order here, right? So these are our output pins going into our root node here. So I'm going to save this, and I'm going to change the order here a little bit. So we want our base color, then we want our metallic, so it's going to be 1 here. Then we want our specular, our roughness, our normal, and then our AO should be last. So I'm going to save on that, go back in here, and now you can see that our pins are ordered in the same order as the pins here, and it just makes it much cleaner when you view it in the material editor, right? Now, one note on ambient occlusion is a lot of people think that you can't use it in Unreal Engine, but you actually can. And I believe in the latest version of Unreal Engine, this is done by default, but if you go into Edit and Project Settings, and start typing in static lighting, you'll see that there is an allow static lighting checkbox. You want to uncheck this unless you are actually going to be doing baked lighting. This will free up enough of the G buffer or a section of the G buffer for the ambient occlusion to work on the material system. Okay, so AO will work if you have that disabled, which in most cases you're going to be using dynamic lighting anyway, so you don't really need static lighting enabled, and that's kind of what Epic Games is moving Unreal Engine towards anyway. Cool. So we've done all this. This is our master material, and this is our material function with all the texture samples in it. Going to close all this. I'm going to go back into our instances surface and then go into our masters, and I'm going to create an instance off of this example 2. Okay, so it's going to be example 2 instance, And I'll throw this into our instances, surfaces, or surface. Now another thing I'm going to do here is actually under instances, I'm going to create another folder. I'm just going to call this, just going to call this one simple. You might have to change it and then change it back again if you want to change something from a lowercase to a capital. And then I'm going to go back in here. I'm going to take these instances and throw these into simple, just so it's a little bit easier to view. And I'm back under surface. So this is the one we just created with the texture sets, right? So what I'm going to do is I'm going to duplicate this front shader ball here. Okay, I'm just going to move it forward 256 units. And then I'm going to take this instance and throw it on it and load this instance up. And just like we did before, we're going to go in and change the parameters. So you can see the only parameters I have for this now are textures, right? So I'm going to expand this. And now you can see we have our textures here. So I'm going to check these three boxes to be able to replace these textures. I'm going to go into our surface folder under textures, and I'm going to just plug these in. So once again, I ordered this vertically the same way that they're going to be laid out horizontally in the content browser. This makes it much easier. So I know my albedo is going to be first, my MRAH is going to be second, and our normal is going to be third. And now you can see that that is showing all of those values on the surface. All right, and the last thing I want to show you is how to do tiling for these textures. So once again, these are just the more basic ways of doing all this stuff. This gives you a good foundation. There are more advanced things that we'll get into in later videos. So I'm going to load up the material instance. Once again, from the instance, I can go to the parent, or the master. And then I can also go into the textures folder here, or the textures material function, right, that we already set up. So essentially on all these textures, we have a UVs input. You can adjust the UVs of the textures. Now this is a single texture set, so we want to manipulate all three of these UVs together, right? So the normal, roughness, all that good stuff moves together. So what I'm going to do is I'm going to go in and create another material function. Let's again right-click, Material, Advanced Function. So I'm just going to call this Surface Adjustment Basic. Actually, for the purpose of the tutorial, let's just do Surface Adjustment. Okay, I'm going to load this up. And what I want to do here is I'm going to create the couple nodes to allow us to tile. So I'm going to hold one, I'm going to left click. I'm going to right click and look for something called a chord, a texture coordinate, COORD. Okay. And then I'm going to add in a multiply. So I'm going to multiply the texture coordinate by this one value. I'm going to convert this to a parameter. I'm going to call this tiling, give it a sort priority of 0, default value of 1, which will be the original texture size. I'm going to call this B surface adjustment for the group, right? So this will allow us to have our surface adjusted. And I'm going to call this output here UVs, because that's what it's going to plug into. Bring this in here. I'm going to group all these. I'm going to call this surface adjustment. I'm not calling it tiling because I'm going to add a few more things in here a little bit later. Let's just give it some random color. There we go. Usually when you do your comment nodes, you want to have them, each one be a different color, at least within the same function or material graph, just so it's easier to figure out where they are. So I'm going to hit save on that. I'm going to find it in the content browser. I'm going to go back into our example 2. And I'm just going to drag that in here. Actually, sorry, not in here. It's going to go into our textures PBR. So I'm going to drag that function into our other function. So you can use functions within other functions. And what I want to do is I'm going to drag the UVs for each of these into this UVs pin. So they'll all use the same tiling value that we just created. I'm going to save that, and I'm going to go back into our Material 2 instance. And now you can see we have our B surface adjustment. Now the reason I put B before is so it'll sort alphabetically, right? So it'll have this group first, this group second, etc. So now I can go in and adjust the tiling of our surface. All right, so the last thing I want to touch on is going to be the parameter collection. So a parameter collection, once again, is a a collection of parameters that allows you to modify material values through sequencer and a couple other subtools in Unreal Engine, but we're going to focus on sequencer for this one. So I'm going to right-click in my parameters folder. I'm going to go under materials, and I'm going to create material parameter collection. I'm just going to call this params001. I'm going to double-click this to load it up. Now in here, you basically have two different arrays. You have scalar and vector parameters. So scalar is going to be that 0 to 1 value I was talking about. It can obviously go below 0 or above 1, but it's essentially black and white values. And then vector parameters can be X, Y, Z, UV, color values, all of that. So what I'm going to do is I'm going to go in and create a scalar parameter for our metallic, specular, and roughness values. So I'm going to hit plus here on these scalar parameters. So we have 1, 2, 3. I'm going to expand these, and I'm going to give them the corresponding names. So metallic, specular, and roughness. And it'll automatically sort in the order that they're laid out here. And you can obviously grab this little dotted grid over here to re-sort them if you want to. You don't have to worry about sort priority and all that stuff. Now, once again, I want to give them these default values. So default value 0.5 for specular and roughness, 0 for metallic. And then I'm also going to create a vector param for color. I'm not going to worry about the, actually, no, we can do that. Let's do it. So inner color, and then I will do outer color as well. Cool. So now we have our metallic, specular, roughness, inner and outer color that we can use in this param. So I'm going to save this. I'm going to close it. And now what I want to do is go back to my master material that I created in the beginning, the master example 001. In here, I'm going to load up our color Fresnel. I'm going to go back to our params, and I'm going to drag that in. Now, another way to bring this in is you can obviously right-click and start typing in parameter collection, and then you can choose it from here, same way you did with the functions and all that good stuff. But it's easier to just drag it in from the content browser, which is what I'm doing. So we brought in this parameter collection, but it has no value assigned to it. So it's using the params that we created, but it doesn't know which parameter that we created to use. So I'm going to choose inner color for this one. I'm going to duplicate that, and I'm going to change this one to outer color, right? Now, basically what I want to do is allow the option to use either the instanced values or the values from the parameter collection. So I'm going to save this as is. I'm going to slide this up a little bit. I'm just going to make some room to add these in. So what I want to do is move these out of the way. And I'm going to put the params above the actual the instanced values, like this, and like this. And I'm just going to distribute and align again. And I'm going to move these over here a little bit. So now what I want to do is add in a switch that allows me to switch between using the parameters or not. So I'm going to right click and look for switch, but I want static switch parameter. Okay, this will allow me to make this parameter an instanced variable. So in the material instance, it'll basically have a checkbox for true or false, right? I'm going to call this use params. I'm just going to put it in a group called toggles. Store priority of 0. And then what I want to do is take the A value, plug it in here. And I'm going to take true, plug it into the param, and false will go into our instantiated parameter. So basically, if it's true, it's going to use params. If it's false, it will not use params. Now with this static switch parameter, you can set the default value to true or false here. By default, it's going to be false because it's unchecked. If I check it, then it is on. Okay, so I'm going to duplicate this. And with static switch parameters, or any parameter, for example, that has the exact same name and it's of the same type. So, for example, if these two color values had the exact same name, but they're both color vector 3s, right, color values, it'll only show once in the material instance, but it will change both of these together. So you're basically not allowed to separate them. So if I wanted to have two different parameter values, I'd have to change the name or add like a 1 or a 2 to them, whatever it is. But if they have the same name and they're of the same type, it'll toggle all of them at the same time. And you can have as many as you want of the same name and same type. So I'm going to plug this into here and this into here. So we're basically doing the same thing for both of these, right? So if it's true, it's going to use the params. If it's not, if it's false, it will not, right? So we now have both of these. They're both the same name and they're of the same type. So that means this toggle will only show once in the material instance itself. I'm just going to slide this up here so it's a little bit cleaner. There we go. All right, and then just to keep things organized, I'm going to select all of these. I'm going to align to the right, slide this over a little bit, and I'm also going to align these all to the right, just like that. Okay, let's slide this up a little bit. Now, when they're together and you move them around, it's going to unalign some of the other ones, so it's usually best to do this after you've done all of your moving around. Cool. So all that is good to go. I'm going to save that. I'm going to go back to our instance for that. So I'm going to close this out, load up our first instance. And now you can see we have that use params toggle down here. One more thing I do want to do is I'm actually going to change that group name to toggles. Just makes a little more sense. Okay, now that's been updated. So now we can go ahead and use the params. Now what I want to do also is add that for the surface value. So I'm going to go back into our example 001 here, double click on the surface basics, and I'm going to do the same thing in there, right? So I'm basically just going to copy one of these switches here and put it into our surface basic. I'm going to obviously expand this out so I have a little bit more control over it. Okay, I'm going to go back into our params and bring that in here. So I'm going to do the same thing here. I want to have 3 of these. So one for each of these parameters. So it's already got the params in there. So I'm going to do metallic from the drop down. I'm going to do specular, and I'm going to do roughness. Okay. I'm going to do the same thing as before, where these will sit above the instantiated parameter values. Okay, so we got our metallic, our specular, and our roughness, just like this. I'm going to take these and obviously do the distribution and alignment. And I will bring these back into here. Now I essentially just want to duplicate this twice as well. And same as before, we're going to take these values and plug them into the params, or the static switch, right? So we have our specular, or metallic, specular, and roughness. And then if it's false for all of these, it's going to go to the instantiated value. If it's true, it will go into the parameters collection. Okay, so I'm just going to order these, or align them. And then I'm just going to align these over here manually. Cool. And then I'm just going to bring them in a little closer. There we go. So now we have the same parameter collection adjustment ability for our surface values, right? So metallic, specular, and roughness. Now, this use params is still in the same group. It still has the same name throughout all these, including in the color for now. So it's only going to show once, even though it's in multiple functions. So keep that in mind. If you're using multiple functions in a material and values inside of this have the same name as another function that you're using in that material, it's only going to show once, which is very useful, but it can also be an issue if you're not intending to do that. So just keep that in mind. Now, one other thing to keep in mind is these param values, you can only have one param sampled per material. So what that means is, like in here, I have this param 001, I have metallic, right? That metallic, let's say I use multiple instances of this material using this material function on multiple assets, but I want to control them individually. I have to create a parameter collection for each one of those that I want to control separately, because anyone that is using that parameter collection is going to be changed at the same time if I'm controlling it with a parameter collection through Sequencer. Okay. So we've done all that. We have our master material already set up because it's assigned into these functions. That's another great thing about material functions is any time that you update them, it'll automatically update any materials utilizing them because it's a prefab, right? So I'm going to close all that, save that out. And then what I'm going to do is go into this instance B that we created. I'm going to enable use parameters. So as you can see, it's going to go back to the default values, and I can't change anything in here except for the color for Nell because it's using param. So if I uncheck that, those values are there. Anytime you use a static switch or static switch parameter and you change it to true or false, it's going to disable the parameters in the instance that it's no longer referencing, right? So now that I've done that, I can now go in and let's say create a quick level sequence. Let's create a new folder. Call that example 001. And I'm going to get rid of the curves editor. I'm just going to throw the sequencer window down here. And then what I want to do is I want to go into my sequence. I want to right click and create a material parameter collection track, and I want it to target the param collection that I created. This is why I was saying you can only control one set of parameters for any asset that utilizes it, right? So if I had all three of these, let's say I had all three of these utilizing the same master material, even though they have different instances, and I'm using parameters, it's going to affect all of them just because the parameter is only being edited once in Sequencer. So now that I've added that params track, I can go and hit the plus, and I can add the parameter values that I've created, right? So I can do my inner color, my outer color, my metallic, roughness, and specular, and then I can expand this. You can see those values here that I can now adjust, right? So I'm going to close the instance down for a minute. I'm also just going to change this to show time as seconds. I'll do another video later on sequencer in general, but this is specifically for these material attributes. So you can see I have keys set up here already. I'm going to make it so it automatically keys. And you can see my inner and outer color, right? RG and B and alpha. So right now it's all set to black. So I'm going to let it progress, let's say after about 2 seconds. I'm going to have it go into red for the inner color. And I'll have it go into blue for the outer color, right? So as I slide that, you can see it's adjusting. And then from there, I'm going to add a key for my roughness and metallic. Or sorry, roughness and specular. So when I get to frame 4, or 4 seconds, I'm then going to adjust that. So I'm going to make the roughness 0 and specular 1, right? Okay, so it goes from black into red, and then it goes fully non-rough. And then at the 5-second mark, let's just make our metallic 1. Okay. And I'm also going to set this so it loops. Go back to the beginning, hit play. Right, so you can see those values of the parameters changing via sequencer. And obviously, if I wanted to go in and let's say I set our playhead to 10 seconds, let's just do 8 seconds. I can then set that as our endpoint. And then what I can do is take all these original values. I'm going to copy them. Let's do it to like 6 seconds. Paste those there. Now I also want to take these values that do not change and move these keys really quick. So it doesn't, interpolate between here and here. It should be there and there. Okay. So then all those values should go back to normal. So if I click on the very end keys and the beginning keys that are the same. So now if I play it on a loop, you can see it's going to be a nice looped cycle where it goes back to where it was originally. Cool. Like I said, once again, I'm going to do a video on sequencer a little bit later, but that is everything for the material parameter collections, right? Cool. Now, if I go into this material instance, once again, this is material instance A, this one is material instance B. But if I go into this material instance A and I tell it to use params, once again, it's going to only be controlled by that same parameter collection because we only have the one. If you want to have different parameter collections controlling the same thing, you're basically going to have to create duplicates of them and give them different names. All right, so that is going to conclude this video. Hopefully you found it useful and found some good information in it. I will have more videos coming in the not too distant future.